Cool. Right? This is the color. So the yellow color represents the chocolate price history, and the blue color, on the other hand, represents the future prediction. Hey guys, how's it going? Welcome to Louis Python. Today in this video, I will start a new machine learning algorithm called Rainforest Regressor. This algorithm is from scikit-learn as well, which is similar to the k-means I talked about over the past 2 days. And this algorithm is different with k-mean because it's usually used to predict a value. For example, gasoline upcoming 6 months future price. Developers or engineers often would pick this one, predicts the value or the number based on what historical numbers they have. And today is the same. I would like to take recently a very popular and booming commodity, chocolate, cocoa, the commodity price in upcoming 6 months. So let's see what the algorithm would deliver to us. And before the video, I think there are 2 things I would like to say. One, today's video is not for investment suggestions. Please know that. It's just for a method for your reference to use if you like to predict a value using machine learning algorithm Rainforest Regressor from a methodology perspective. So don't put this video as your investment advice or suggestions, okay? And second, again, please remember to subscribe our channel and turn on the notification. Your support is very critical to us. Thank you for your support as always. So let's move forward and get started. There are 5 steps in this video. The first 2 steps I already been prepared because it's a very regular work, very ordinary work. For example, the first one is set the configuration and import some modules. So as you can see, we will have the environmental variable access, Google Colab and user data. We need requests to fetch the API data. We need pandas to manipulate the data. But apart from them, we also need daytime under day until, because we have some of the data type to manipulate it compared to the other videos we shoot on the other days. And also the algorithm today we will import scikit-learn. From scikit-learn is Rainforest Regressor. And last but not least is the data visualization, which would visualize the commodity cocoa historical price and also the prediction price as well. And the next step is to fetch some live commodity data. As mentioned earlier, we will use the cocoa data applies to the scikit-learn's Rainforest Regressor's algorithm. And then here we use the external third-party API and try. This is the results from the API, and the historical data is since 1980. Okay, so from step 3, let's get started together. First thing first, I would like to turn this fresh data list into a data frame. Let me print this out, have a look. Great. It has 2 series, one is date, the other is the cocoa weight. Okay, perfect. And the next step, I will try to convert this date. We can have a look at the information first because I like to double confirm the series information. Cool. So right, the date here is just an object. It's not the date data type yet. So what I'm going to do here is to turn this date data type into a real date data type. And what I will do, 1 date and PD. There is a method called to date time. This is a pretty useful, helpful method. Please remember this, guys. I use this quite often. And then I try to print again, also print the information. Okay. Cool. Date time 64. Perfect. After this, I might also set this as the index because in the final step, we will visualize the data in a time series chart. And in time series charts, index can be the x-axis as the date, and the matplotlib, to this the visualizations library we use, will automatically turn to use the dates and then plus to the x-axis. So let me set the index date, and then in pace true. Right? Sorry, df1. Cool. Date as the index. And the next one is released to add a series called next month, because so far we just have the current or maybe yesterday or maybe close rates. Let me call this close rate because it is the latest month. So in stock, right, there's open rate and open price and close price. We can call this is the latest recent price from cocoa because it's split by month. But we need to add the next month because now our object is to predict next month, right? So all this data is the historical data. Next month, global rate. What I would do is sheet a row. Let me print this out. And the current data thing, from my perspective, has two problems. First thing first, it's very difficult for us to just describe what is good result and what is bad, right? And at the same time, the second problem is for algorithm as well. They not able to help us automatically to just describe what is bad and what is good. So I will add the other series here, which is called the target weight, and define the object, what is good result and what is not. And target rate. And I will set a classification here if next month, which is next month, oh, not this, next month is greater than the global chocolate rate. There is a result which is a 0, 1. Let me print this out to show you guys. Okay, so as you can see here, there is a new series called target rate, and it is a Boolean 0 or 1, or you can say this is a classification. So what that means? 0 means represents the way is equal or less than the next month is equal or less than the latest historical chocolate rate. Because I said the standard here is if greater, it would be 1. Okay, for example, here is 4,000 blah 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 is greater than 3,600, so it would be 1. Okay, and this is much easier for the algorithm to understand what is the result we are looking for, right? And the next one, and because now the window is too long, right? Since 1980, I would like to shorten the window length. And here, data 1, data thing 1, data thing 1, I not. Maybe this. I know here is quite similar to Python name. Okay, it's the last data thing from 150 rows to the end of the data thing. And then df, I just create the variable name. It doesn't matter what variable name you want to create it, right? And df1 reset the index. I try to reset here first. Yeah. And URL df3, URL df22. I drop all the non-value, the non-value. I try to print as well. Cool. Okay, that's great. And yeah, now it became since 1992. And then we can start writing the scripts to predict the trichotic pricing using the existing data frame. So first thing first, because now we predict in the upcoming 6 months, so we can have a loop 6. And the data set for prediction. For example, X here. We will use 2 features, 2 data series. The first one is the next month. Let's memorize the feature name. Yeah, correct. And target weight. Okay. And we will use the whole list of the data frame. So we are able to add this link here to make sure we make use of all the instances from a data frame. And the label, we will set the global weight. Trichotic price monthly. Okay. And again, here is the Y. X name Y. Okay. And because now the algorithms class object is ready, so we are able to fit the data frame. I mean, the existing data set. I just mentioned these data frames to fit to this algorithm X and Y. And this step basically is we use the latest update data frame data sets and fit to the algorithm, and the algorithms will learn from the data, and then based on this kind of patterns to predict the new features we would put into in a moment. Okay. And the new data would be next month. Target rate and tail. The new data's variables instance rows of data means that we will use the latest features next month and target rates and put into the algorithm's object predictions and help us to guess the next month features value. So and this kind of the new data will be updated from every loop. So the first round we have next month is March, and the second loop would get the April prediction. So we will use the tail, which means every time we just use the latest instance, which means the latest row of value, to update the day value from the index as well. And at the moment, because I just reset the index, now state data value is a series. So I create a new variable name next month value. Put here, and date time string. Now the data type is a string, even though the value shows is a day value. So I need to convert the string data type into date data type first, and then tell date and values 0. And then we'll try to manipulate a little bit a speed to t. I just need the plus before t. So I set 0 here, and then make sure the date format would be year, month, and date. Okay. And because now we need to add the next month value, because now the latest dates value in our existing dataset is February, so we will need to add the next month, March, and March next loop would be April. So here is the day after month, and we will need to use the library we just mentioned earlier. So we import the Python packages is the day until, relative delta value, relative delta, and once past month. Okay. And now the date change variable has been ready, and the next one will be the predict value. Predict value. We have the algorithms class. We predict the value using the latest one from the existing data frame. And the next one is we assign the predict value to a variable, and then we can put it into and express decimal places. So I create a variable called predict value next month, and I will use round. I copy the predict value here, and then the outcome here, the output here is from the module prediction is in a list data type. So I will select the first one. The first one is 0, is the news predict number, and I will keep 2 decimal places. Okay. So let me to add a print here. We can have a look later on when we start the loop here. And last but not least, I would to consolidate all this data into a dictionary data type. And here, in the dictionary data type, all the keys should be the same, which I means we should use the same set of the keys which in this data thing, because at the end I need to plug this latest instance back to the existing data thing, and then loop again to use the new predict value to predict the next month value, right? So here is the date, and I use predict days after month. Okay, and then next month to predict value next month, which we just create. And the global chocolate price. Here is the new data next month. This is the data thing, right? And use the data fund, and then I guess the value here. And the next one is the target rate. Target rate. And for target rates, I would need to create a function here. As we remember, right, what is the definition of target rate is the next month is greater than current month chocolate rate. So I will need to create a function which to satisfy whether the predict value is greater or less than the current month value. So here I just create 2 arguments, and then so first, if value 1, which is the next month, greater than value 2, which is the current chocolate price, the target value would be 1. Else, the target value would be 0, and returns the target value. Right? Okay. So I will use this function. I will put here. So float first. Predict value. And then float. This is the calculate rate. Okay. Let me elaborate a little bit here because now we are using two instances, right? New data series next month, the value 0 means that we use the not the predict instance, we use the latest instance we used to predict. And this next month price should be the latest instant we predict sits in the current chocolate price, right? So that makes sense. So I will put the value here. And then last but not least, the data frame here, we need to update the data frame, which I need to insert the latest instance to the data frame. I use this lock methods from the pandas and then insert this dictionary data. Okay. So now the prediction part is ready. Let us do loop it. Okay, it's done. Right? So we will have the latest one is the latest chocolate price from our third-party data provider is to February. And here, as you can see, because now we predict in the upcoming 6 months, we have March, April, May, June, July, and August. Sorry. So totally, there were 6 months. Okay, it's cool. It's done. And the next one, I was to set the data set. Okay. The index. Yeah, I need to set it back because just now, just wanted to show you guys why I need to set the day as index. Now, I need to set it back because in the loop, I need to add the month, the predict month value as well as the predict chocolate value. So here is the date and in place equal to true. Okay. Is it date, right? Oh, I'm sorry. It's not a variable. It's a key. Date. Cool. Okay. And then I try to shorten the length of the date window because now it's too long. Trace back to 1992. Maybe I said I lock. And why I set the -5 here, let me elaborate in a moment, okay? And I try to print this one out as well to have a look. And then to dear free I lock 100. And then reprint this as well. The reasons I set two data frames here and select the different length of the series is because in a moment we would create a visualization chart, right? This is the time series chart. I would like to separate these two lines and visualize much better because now we have a time series line which exclusively have the predict value compared to the other. So you guys can clearly very straightforward to see what would be the predict value in the time series chart. Okay, and the next part is create the chart use the matplotlib. So I create a figure size, and then 22.8. I don't know. It depends on your project, but yeah, I just show the sample here. Plot. I use the data frame, the first one here, because now we will have two time series line. This first one is historical chocolate price time series line, and here is the chocolate price series, and I set the line with A maybe, and the color, I don't know, I just nice to use this one as always, and I label the name chocolate price history. Okay, and I try to copy this as well and use the second data frame we just created here, and this one would be next month, and then refine a little bit thinner, it doesn't matter honestly, and find F4. Okay, and this is the future prediction of chocolate price. Okay, and X label, date, font size 15. You can set smaller or bigger, it doesn't matter. It really depends on your lead. And right label, price US dollar, because the chocolate pricing unit currency unit should be dollars. Yes, it's dollars. Okay, and font size 15. And I usually love to add the grid as well. Okay, the title, chocolate monthly price, font size might be a little bit bigger, 25. And the X-text rotation. The X-text rotation here means that's the date. We show the dates in the x-axis which are not in the horizon format, right? Because the dates would include the year, month, and date and day. So it would not look great if you put them in a horizon format. So I set a little bit rotation, 40 degree. And months here is the mandate, year, locator. Okay, and GCA, XSS, set, sorry, here is typo. Set, major, locator, months. The GCA, here's your heifer, and XSS, set, major, formatter, mandate, and the date format should be year, month, and date, right? And okay, and then I will add the legend lastly as well. The legend, title, commodities, price, present, and future 6 month. Is right, 6 month? Yeah, 6 month. prediction. Oh, sorry. And I will push the legend on the upper left. Location, upper left. And the font size 10. And I would like to set the color separated between two lines as well. So I will add label here. I will copy the label name, chocolate price history, and also add future prediction here, right? Yeah. Okay. So the purpose of this label setting here is because we have different color represents different price data sets, right? So I put here, and Matplotlib can automatically identify, okay, chocolate price history is in this color code. So when Matplotlib produce the time series chart, it will automatically add this color to the legend. It means this color goes to the legend, to the chocolate price history in the legend. Let me show you. Cool. Right? This is the color. So the yellow color represents the chocolate price history, and the blue color, on the other hand, represents the future prediction. Great. It's done. So as you can see here, there's two time series lines. One is history data, the other is prediction. And just mentioned, as mentioned earlier, I said here the prediction line is a little bit longer compared to the historical line, because I can much clearly identify what would be the upcoming 6 months trend in terms of the results and the outputs from the algorithm prediction. And here is the date in the x-axis. Okay, cool. That's it. This is the algorithm we use to predict the chocolate price. The algorithm is the Rainforest Regressor. You guys can try not only chocolate, you can try oil price, gasoline, gold, stock price from a ticker, whatever. I just want to show you the methodology and then terminology we use, and also the process how to train the model and use the models to predict the upcoming value. Having said that, I don't think these predictions can be applied to realistic and authentic investment. I think this is the way for you to get used to using the algorithm of Rainforest Regressor, and then if you have sufficient data set, you can have a very short-term upcoming time frames to see what would be the value. I think this is support for your project or maybe strategies determination, but not for investment. It's just for your understanding what is the standing point or perspective from the algorithm. Okay, so that's pretty much. I hope you guys enjoy watching my video regarding the Rainforest Regressor, and let me know if you have any comments and ideas regarding the machine learning algorithm. I can prepare the other video as well. So hope you guys enjoy, and I will see you next time.